Hello students. In the previous video, we have studied about the potentiometer and its applications, and today in this video we are going to see some numericals based on its applications so that we can understand better how a potentiometer works and how we can use it practically in the laboratory, right? So here I have picked some questions for your better understanding. Let's begin with question number first. So question number first says that if we have a potentiometer wire 10 meter long and has a resistance of 18 ohms, means a potentiometer wire which is 10 meter long have a resistance of 18 ohms connected to a battery of EMF 5 volts and internal resistance 2 ohms. So we have to calculate the potential gradient along the wire. मीन्स एक पोटेंशियोमीटर वायर है जिसका लेंथ 10 मीटर लॉन्ग है एंड उसका रेजिस्टेंस 18 ओम्स है एंड दैट wire is connected to a battery of EMF 5 volts and internal resistance 2 ohms. Now we have to calculate the potential gradient along the wire. So let's see how it will work. So first we will see what is given in the question. So we have the length of the wire, that is 10 meter, resistance of the wire, that is 18 ohms. That wire is connected to a battery of EMF 5 volts and that battery has internal resistance of 2 ohms. Then the current through potentiometer wire, we know that the current through potentiometer wire will be current is equal to, now we know that Ohm's law states that potential upon resistance. So here the applied potential or EMF is epsilon and the total resistance is the resistance of the wire plus internal resistance of the cell. So we are going to substitute these values here and the current through the potentiometer wire that we will get will be 1 upon 4 amperes. Now we wanted to find potential gradient. So potential gradient is potential per unit length, that is V upon L, and V according to Ohm's law is IR and the current that flowing through the circuit is 1 upon 4. So current flowing through the wire is 1 upon 4 and the resistance of the wire is 18 and the length of the wire is 10. So we will substitute all these values and the answer we get will be 0.45 volt per meter. This is the required potential gradient along the wire. Okay, so now come to the next question, question number 2. Question number 2 states that a potentiometer wire is supplied a constant voltage of 3 volt. A cell of EMF 1.08 volt is balanced by the voltage drop across 216 centimeter of the wire. Then we have to find the total length of the potentiometer wire. Means we have a potentiometer wire जिसको हमने एक constant voltage supply 3 volt से connect किया है and then the cell, now the whole wire is connected to this much constant voltage, right? So if we want to take whole length balance, then that whole length is proportional to this voltage. But if a cell of EMF 1.08 volt has to be balanced, means अगर हम इतने EMF को balance करना चाहते हैं, then this much EMF get balanced at the length 216 centimeter. Means this is proportional to this. We know the principle of potentiometer that states that epsilon is directly proportional to length. जितना ज़्यादा voltage उतनी ज़्यादा length. That means this much length is balanced by this and we have to calculate कि इतने voltage को अगर हमें balance करना है then how much length will be there. What we have to calculate, अगर इतना वोल्टेज हम अप्लाई करते हैं तो दिस मच लेंथ गेट्स बैलेंस्ड. सो अगर 3 वोल्ट्स हमने अप्लाई किया है तो टोटल लेंथ, ये टोटल जो बैलेंसिंग होगा वो कितने लेंथ पे होगा. सो हैव वी हैव टू केसेस. इफ़ वी अप्लाई 3 वोल्ट्स देन उसके करस्पॉन्डिंग लेंथ हमको कैलकुलेट करना है. if we apply 1.08 volt, then उसके corresponding length हमारे पास already given है, that is 216 centimeter. So taking the ratio of these, we will get epsilon upon epsilon 1 is equal to L upon L1, and substituting the values, we can get the value of length L, means the total length of potentiometer wire, because the total length is balanced by the total constant voltage. So इसके corresponding जो balance length हमें मिलने वाला है, it will be the total length of the potentiometer wire. So length L is equal to 3 upon 1.08 into 216 centimeters. So this length will also be in centimeters. So L is equal to 600 centimeters. This is the total length of the potentiometer wire. Let's move to question number 3rd. So in question number 3rd, a 10-meter long wire of uniform cross section of 20 ohm resistance is used as a potentiometer wire. Means potentiometer wire that we have is 10 meter long and is of uniform cross section with a resistance of 20 ohms. Now this wire is connected in a series with a battery of 5 volt along with an external resistance of 480 ohms. Now this we can also see in the diagram that the potentiometer wire which has resistance of 20 ohms is connected to a resistance of 480 ohm, external resistance of 480 ohm in series, and a battery of 5 volt. Now if we want to balance an unknown EMF, this unknown EMF epsilon we want to balance, so we have to calculate this EMF epsilon and the potential gradient. What we have is an unknown EMF epsilon. अगर हम इसको balance करते हैं, then it get balanced at 600 centimeter. This length is given कि ये जो आपका जॉकी है वो no deflection वाला condition 600 centimeter पे show करेगा. That means this EMF epsilon is balanced on 600 centimeter length. Then we have to calculate this EMF as well as the potential gradient. So first we will talk about potential gradient. Potential gradient is V upon L, like right, potential upon length. So to find potential gradient we need two things, V and L. Alright, what we need is V and L. Now this is the length of potentiometer wire that is given in the question, 10 meter, so it will be 1000 centimeter. So there is no problem of length L. So we have to calculate capital V, means potential difference हमें calculate करना है across the wire. What we need is potential difference across AB. So potential difference we know according to Ohm's law, V is equal to IR. So if I want to know potential difference across AB, I'll put it IRAB, means current across AB into resistance of AB. Now in this value, current we don't know, resistance we have in question, that is 20 ohms, but current we don't know. So first of all we want to find the current. Now current is equal to जितना current इस पूरे circuit में flow करेगा, that is the current in the wire AB also. So इस circuit का current अगर हम निकालेंगे तो it will be I is equal to V upon R. इस circuit में voltage है 5 volt and resistance है 20 plus 480. So जो current की value निकल कर आई 0.01 एम्पियर हो गई. Now this much current is also flowing through AB. इस पूरे सर्किट में यही करंट है और AB के अक्रॉस भी यही वैल्यू है करंट की. सो AB के अक्रॉस पोटेंशियल डिफरेंस हो गया दिस मच करंट इनटू रेजिस्टेंस ऑफ AB, मींस 0.01 into 20 or 0.2 volt, and length of the potentiometer wire is 1000 centimeters. So potential gradient is 0.2 upon 1000 or 0.0002 volt centimeter inverse. Now we want to find the unknown EMF epsilon. We know that epsilon is proportional to L and epsilon is equal to potential gradient into L. This is the actual principle of potentiometer. So we know the potential gradient. Here we have calculated the potential gradient for the potentiometer 0.0002, and epsilon के corresponding का balanced length we already have in question, that is 600 centimeters. So we substitute it here and we will find epsilon and we get 0.12 volts, right? So by calculating potential gradient, we can find unknown EMF corresponding to any balanced length. And to find potential gradient, we need potential upon length of potentiometer wire and potential across that wire, right? Okay, let's move to question number 4th. Now, in this question, the length of potentiometer wire is 5 meter. It is connected to a battery of constant EMF. Now, for a given Leclanche cell, the position of zero galvanometer deflection means balanced point, is obtained at 100 centimeter. For a given cell, the balanced point is at 100 centimeter. If length of potentiometer wire be made 8 मीटर इंस्टीड ऑफ 5, दिस 5 मीटर को अगर हम चेंज करके 8 मीटर में कन्वर्ट करते हैं, देन वी वांट टू कैलकुलेट द लेंथ ऑफ वायर ऑफ जीरो डिफ्लेक्शन इन द गैल्वेनोमीटर फॉर सेम सेल. ऑलराइट, सो हमने सेल सेम रखा है और हम बैलेंस्ड पॉइंट ही कैलकुलेट करने वाले हैं फॉर द सेम सेल. बट जो वायर पोटेंशियोमीटर वायर हम पहले 5 मीटर का यूज़ कर रहे थे केस 1 में, केस 2 में हम 8 मीटर लेंथ का वायर यूज़ करेंगे. सो वी कैन राइट इट एज लाइक केस 1 एंड केस 2. केस 1 में लेंथ ऑफ पोटेंशियोमीटर वायर इज़ 5 मीटर, केस 2 में 8 मीटर. केस 1 में लेंथ फॉर द बैलेंस्ड पॉइंट और ज़ीरो डिफ्लेक्शन पॉइंट इज़ 100 centimeter for that given cell or 1 meter, and in case 2 we want to find that, right? We are not changing any EMF or any battery, so total EMF is proportional to this length and IR for that cell is proportional to the length L, right? So epsilon upon IR represents, this is the EMF for the Leclanche cell जिसको हम बैलेंस्ड करना चाहते हैं, एंड दिस इज द कांस्टेंट EMF across that wire, whole wire. So epsilon upon IR is equal to L1 upon L, and in case 1 and case 2 this quantity will remain same because we are not changing the cell or EMF across the potentiometer wire. So in case 2, L1 dash upon L dash will also be equals to epsilon upon IR. Means for cell first केस में पॉइंट था, जो लेंथ था वो L1 था. फॉर द सेम सेल ऑफ EMF एप्सिलॉन, जो सेकेंड केस में लेंथ है वो हमें कैलकुलेट करना है. सिमिलरली इन केस 1 टोटल लेंथ के लिए जो EMF था क्रॉस इट वाज IR in case 1, and in case 2 it was also IR because we are not changing any quantity, we just change the length L and L dash, right? Now comparing equation 1 and 2, we get L1 upon L is equal to L1 dash upon L dash. On rearranging these values, we can find the required length L1 dash, that is the length of wire of zero deflection in galvanometer for the same cell in second case, and we get it as 1.6 meters. Okay, all right. Let's move to the last question of this video. So question number 5. In question number 5, this figure is given. Here we have the potentiometer wire AB, 1 meter long. Now the wire is uniform and has a resistance of 10 ohms, right? Rest quantities are shown in the diagram only, and we want to calculate the potential gradient along AB and length AO, this length AO, where G shows no deflection. If O is the point where G shows no deflection, then we want to find the length AO. All right, let's see the solution of this question. So first of all, we want to find the potential gradient along AB. We know that potential gradient is equal to potential difference upon length. So what we need is the potential difference across AB upon length of AB. Length of AB is known, that is 1 meter or 100 centimeter. So the task is to find the potential difference across AB. right? So to find potential difference across AB, we know that the value of this will be current across AB into resistance of AB. Means if I want to find potential difference across AB, it will be I into RAB as per Ohm's law. So the task is to find current, because RAB we already know. This is given that the resistance of the wire is 10 ohms. So RAB we know. We are going to find the current I. Now current I can be found by using this primary circuit, right? So the current flowing through AB is the current that is flowing in the primary circuit. So in primary circuit, current I can be found as I is equal to voltage upon resistance, and this EMF or the voltage is 2 volts, because primary circuit में हमारे पास 2 volts का EMF है, and this resistance is 15 plus 10, right? 15 plus 10, because primary circuit में total resistance है wire का plus 15, that is 25 ohms. So total resistance of primary circuit is 25 ohms. EMF in primary circuit is 2 volts. So the current is 2 upon 25, that is 0.08 ampere. So when we find current, we put it here, and we can find the potential difference across AB. So potential difference across AB is 0.08 into 10, that is 0.8 volt, and potential gradient will be potential difference upon length. So potential difference is 0.8 upon 100, and the result will be 0.008 volt per centimeter. This was the first case, first question. Now the second part is we want to calculate the length AO where galvanometer is showing no deflection, right? So according to the principle of potentiometer, epsilon is equal to होता है KL, right? We want to find this length. If I want to find length of AO, what I should have, potential difference और दिस EMF एप्सिलॉन जिसको हम बोल रहे हैं, पोटेंशियल डिफरेंस अक्रॉस AO अपॉन पोटेंशियल ग्रेडियंट. पोटेंशियल ग्रेडियंट वी हैव कैलकुलेटेड, तो हमें उसका कोई प्रॉब्लम नहीं है. नाउ द टास्क इज टू फाइंड पोटेंशियल डिफरेंस अक्रॉस AO, right? Potential difference across AO. Now potential difference across AO, let's see in the diagram. We want to find potential difference between the points A and O. Now these are connected in parallel. Now the potential difference across AO will be same as the potential difference across this terminal. Means potential difference across AO is equal to potential difference across 0.3 ohm resistance in zero deflection condition, right? So basically we are going to calculate potential difference across 0.3 ohm resistor. Now if we want to find the potential difference across this resistor, then it will be current across this resistor into resistance, means I into 0.3. So हमें चाहिए current जो इस terminal में flow हो रहा है, right? So इसके लिए हम secondary circuit का use करेंगे. Let's see how we will use the secondary circuit. So resistance of secondary circuit is this. इस secondary circuit में कितना resistance है? 1.2 plus 0.3, और कितना voltage है? That is 1.5 volts. EMF is 1.5 volts. So secondary circuit में resistance is 1.5 ohms, EMF is 1.5 volt. So current in the secondary circuit is 1 ampere. Means EMF upon resistance 1.5 upon 1.5, that is 1 ampere. Means ये जो हमारे पास secondary circuit है इसमें 1 ampere current flow कर रहा है. That means 0.3 में भी 1 ampere current flow कर रहा है, और 1 ampere current flow करेगा तो इस resistance के across जो potential difference होने वाला है, it will be 1 into 0.3, that is 0.3 volts. So potential difference across 0.3 ohm resistor is current across it, that is 1 ampere, into resistance of it, that is 0.3, means 0.3 volts. Now the potential difference across A and O is equal to the potential difference across 0.3 ohms, that is 0.3 volts हो गया. So length between the points A and O will be potential difference upon potential gradient 0.3 upon 0.008, and this is volts per centimeter, so the length we are getting will also be in centimeter. The length AO will be 37.5 centimeter, right? This is how we can use a potentiometer to find the length or to find EMF or to compare EMFs. So practically these are the situations where a potentiometer can be used. So this was all about the numericals based on potentiometer and its application. We'll come with the next video soon. Till then, study hard, stay tuned, and stay safe.